There always comes a time when you'll need to stop using a computer. Leaving it on for extended periods of time could cause screen burn or just waste power. So, if you were done for the day or whenever, you'd turn it off. In the 1980s and most of the 90s, this was entirely a deal of manual intervention with a varying amount of steps. You'd know this if you've ever seen the rather ominous screen, "It's now safe to turn off your computer." Such computers had a power switch located to the side or at the front of the chassis. This switch was wired directly to the power supply, so switching it off would physically cut power to the unit. Many power supplies from this age had two connectors at the back, one which would go to your wall outlet, and another for a monitor to directly pass through. The earliest IBM PCs were designed around using this pass-through connector, so a typical two-connector wall outlet would have room to plug in a printer. What this meant is that the monitor would turn on with your computer, and when you switched it off, so too would the monitor go out. Some monitors continued to be designed around pass-through connectors, but the vast majority to all of them shifted towards plugging into a separate outlet. In the beginning of home computers, very little had to be done before turning off a computer. Certainly in a primitive operating system like DOS, all you had to do was wait for any disk activity to stop and flip the switch. As hard drives were introduced to these computers, the earliest models required an additional step, but this was only applicable if you intended to move the computer. All hard drives have a designated landing zone, which is where the heads will park at and is not used for storing data. Such early hard drives required you to run a program which was capable of parking the heads. If you didn't, the hard drive's platters could spin under the heads placed far into the disk, potentially damaging data. Later hard drives stopped requiring this step, initially by using the platters spinning down as a little power generator to park the heads. This mechanism was superseded by a more instantaneous retraction. As more complex operating systems became more widely adopted, however, a good chunk of them weren't designed around instant shutoff. Especially in multitasking environments, it may be the case that one forgets they left some unsaved work open, and if it's not flushed from memory to the disk, that data can be lost. Or, temporary files managed by the operating system may not get cleaned up, and thereby take up more space. Such operating systems would provide a shutdown command in some form to perform all the required cleanup and saving routines before the user can power off the system. Even later versions of MS-DOS came with a disk caching driver. By default, this only buffered read cache, but if you set it to also use write caching, MS-DOS itself may require a graceful shutdown procedure of its own. It's really nothing more than typing smart drive/C to flush out all the disk buffers. Though if you wanted to restart the computer, pressing Ctrl-Alt-Delete would take care of that automatically. Of course, you certainly wouldn't want to suddenly power off the computer while Windows 3.x is running. Shutdown routines were often expected to be lengthy, and because of this, the user had to be present, waiting for the computer to give the all-clear before turning the power off. Each time this happens, the time wasted waiting there can add up, especially when you consider such computers can be expected to be used for years on end. Wouldn't it be nice if the computer could control that itself? One such device which could automatically power off a computer was an uninterruptible power supply, or UPS. Such a device often included a serial port. This transmitted and received simple signals to invoke powering off the computer or to report to said computer that power has been lost or the battery is running low. Such a device functioned as a convenience mechanism and a means to gracefully shut down a computer in a power outage. Some advanced operating systems, such as Windows NT, included a built-in service to communicate with the UPS. This was especially important in servers which were often left unattended. Starting in the early 90s, however, laptops adopted a different approach. Intel and Microsoft jointly published a specification for advanced power management, which received 2 revisions following the initial version. This existed as a BIOS extension responsible for controlling the power consumption of various devices in a computer. Aside from such possibilities like throttling the CPU on battery power and spinning down the hard drive on inactivity, one feature some laptops became capable of was entering a soft-off state. This meant that power could be controlled with a smaller momentary switch rather than a toggle switch. This did not completely turn off the computer, but consumption could be drastically reduced to just a few watts at most, preserving battery life and giving roughly the same effect of if the computer was actually unplugged. The majority of components have their power cut off by the computer itself, leaving only enough to respond to a power switch's signal. Initially, this feature only existed in laptops, as far as PCs go anyway. Desktop computers supporting APM could still throttle or stop many components to conserve power, but they were not capable of switching everything off due to the inherent limitations of the AT power supply. To address this shortcoming, Intel introduced the ATX standard. One of the key features of this specification was the introduction of a completely new type of power supply capable of entering this soft-off state. This specification was primarily designed for the new vertical form factor of ATX motherboards, which is still in use today. However, as the transition from the old AT form factor to ATX was a huge one, many case and motherboard vendors took both standards into account. Early ATX cases allowed you to mount an AT motherboard if need be, and AT motherboards throughout the late 90s implemented ATX power connectors to support the new power supplies and their soft power capabilities. In the early days, this was all handled through the existing APM specification. By invoking an interrupt call to the APM BIOS, setting all devices to off, an operating system such as Windows 95 could power the computer off on its own. This was the intended route, but if anything got stuck, you could just push the power button once to toggle the power state. Some motherboards could let you reprogram this button to send a suspend signal instead, and require holding the button for 4 seconds to power off. The APM specification was short-lived, as it was soon superseded by the ACPI specification, which first started appearing in computers in 1998. In fact, ACPI consolidates a lot of functions previously dedicated to other specifications: plug-and-play for automatic device detection, MPS for symmetric multiprocessing, and others. Many motherboards from this time continue to support the older specifications for compatibility reasons, so even on an ACPI-capable BIOS, Windows 95 still needed to use APM on an ATX motherboard to power off the system, as it has no such implementation of ACPI. The first operating system to support ACPI was Windows 98. However, as ACPI was rather unstable at launch, Windows 98 didn't use it by default, assuming your BIOS version was dated before December 1999. Therefore, at the time, it was up to the OEM to decide whether to use ACPI or not. ACPI offered a number of advantages over APM. Aside from its more elaborate power-saving features, it makes better use of an ATX power switch by allowing the operating system to take complete control of it, and use its signal to trigger suspending the computer or invoking a graceful shutdown at the user's choice. A shutdown procedure in ACPI is drastically different from APM's own, definitely more complex, but it achieves the same effect. However, when Windows 2000 and ME were released, these would also make a different power state more broadly available. Before then, it was often referred to as suspend to disk, but now it's just called hibernation. This function was also defined in the APM specification, but was left to OEMs to figure out their own implementation, and had to be handled in the BIOS. This was most typically present in laptops, but a tad few desktop platforms, such as AOpen motherboards, supported it as well under some strict circumstances. Hibernation basically copies the entire contents of RAM to a hard disk. Upon completion of this copying procedure, the computer would then power off, just as if you had shut down the operating system. Upon turning it back on, the RAM contents and disk would be restored as they were. While it may be possible to see a Hibernate tab in Windows 98's control panel, hibernation still was not managed by the operating system until Windows 2000 and ME. ACPI doesn't power off the computer itself, nor does APM. They send distinct signals to the computer requesting to power off. The computer can successfully dispatch this signal to the power supply if it is ATX, but not if it is AT. ATX in collaboration with ACPI have become the norm for powering off x86-based PCs to this day. Combined with journaled file systems and smarter programs keeping save sessions in the event of sudden power loss, turning off your computer is a lot less rocky than it used to be. You can safely press your computer's power button to do what you ask it to do, and walk away gleefully. However, newer motherboards don't support older versions of ACPI or APM at all, so in the event you were to install Windows 98 or even 95 to one of them, you'd have no power management features on hand. Therefore, you'd regress to the old ways of doing things. One last morbid curiosity I want to bring up is a certain lineup of compact Presario computers from the late 90s, which implemented a very unique way of handling an operating system shutdown. Some computers, such as the Presario 2254, used an AT or AT-like power connector, probably proprietary. This was released in 1998, so it seems clear Compaq was trying to use up some of their remaining obsolete hardware in stock for it. Rather than dropping you to a prompt to turn off your computer, this computer responds to an APM power-off request by suspending the computer. The operating system has definitely shut down and been cleared from memory, but the computer's fans would still be running, and the power light would turn orange. It seems indistinguishable from if it had gone to sleep, but if you hit the suspend button, that would wake up the computer to a fresh boot. Otherwise, you had to reach for the power supply switch in the back to truly turn off the computer. As the suspend button cannot be used to reset the computer, it's extra painful whenever the system locks up. I wouldn't have thought much of this computer if I hadn't grown up using it on occasion in the past, but it's such a fascinating compromise that I haven't really seen in any other computer. To shake things up even further, a very similar looking model from around the same time, the Compaq Presario 4240 ES, does in fact have a true soft-off state. Its own suspend button can function as an actual ATX power switch. That only made what I was looking for all the more elusive until I got the 2254 earlier this year, and proceeded with a highly exhaustive restoration process. Either way, the simplicity and convenience of automatic power-off is certainly something that's here to stay. It's just taken a long time to get off of antiquated standards cloned from a computer that was designed around the idea that just one person would be sitting there